Hello, welcome to my Grasshopper tutorial. Today we're going to be making a parametric louver system. So essentially we'll create a script here that will allow us to have louvers that flow along a surface, that the depth of the louver is relative to the proximity to the curve. So I have the definition built here, and we'll go through it step by step to recreate it from scratch. So just to take a quick look at how this is working, if I hover around here, you can see my louvers are set up where the depth is greatest when it's furthest away from the curve and is almost zero when it is touching the curve. The amount of curves I have is parametric, the size of the surface is parametric. I can change the interval spacing, it's all parametric. I can put that back. I can change the smoothness of the curve. If I lower the interpolation, it starts to level out. I can also change the domain, which is essentially the maximum and minimum depth here. So if I kick this up a notch, we can really extend that. I can also pull it in on the minimum side, pull it out on the maximum side. I can inverse it to have the opposite, where the areas that are touching the curve are the deepest parts. It's an extremely flexible script, and it's also quite simple, but essentially it gives a lot of tools that can be used and manipulated to make this into your own design. So let's start from the beginning and work our way through this. So to do this, I'm actually going to have everything exist within Grasshopper except for just the curve will be the only part that you draw from scratch. In Rhino, everything else will build from scratch in Grasshopper. So to start, let's just create a simple box. So under the surface tab, we will go to the primitive section and we will just do a box rectangle. Oh, take that back. Sorry. We will do a bounding box. We will do a center box. So our center box here, and looking at our center box, it's going to want the base plane, which is XY, which is fine as it is. That's what our Rhino base plane is. It's just looking for the size in the X, Y, and Z. So to give it a size, I'll just create a slider. So you can find sliders under inputs here under the params tab. What I also like to do is just double click anywhere and just type slider, and it pops right up. So when adding a slider, the first thing I always do is I'm going to want to edit it just to get the scale right for what I'm doing. So if I go to edit, I can change the number of digits, and since I'm just creating the size of this, I'll just do whole numbers. But my max, I'm going to do it at 20, and the minimum will be 0. That's fine. So what does 20 mean? 20 is in Grasshopper is always going to be what your Rhino model units are set to. So in this case, 20 here equals 20 feet in my model because my units are set to feet. So 20 feet here. I'm going to make a copy of this slider for my X, Y, and Z. So if I just highlight it, Control C, Control V, I can make copies. This way I can independently change how big I want it in my X, Y, and Z. So I'll plug those in here. And first thing I'm going to do is actually turn off the old one so that we're only seeing what the new things we're making. So I'll select everything, right click, and turn preview off. Now we can see our new cube here. So as you can see, 20 by 20 by 20 cube here, but we want quite a bit more width. So I'm going to edit my box in the X direction to give us some more width. So I'm going to edit that. I'll set my max to 100 feet. Click OK, and we'll bump that up. So now we just get a nice long surface so we can start to see that change over a greater distance. Next thing we want to do to break down this box, you see if we click on the box, it selects the entire box, but I don't want to work with the entire box. At this moment, all I want to do is work on this individual face. So what I need to do is explode this box so that I'm working with just the relevant edges of it. So first thing I'll do for that is I'll go under Surface, Analysis, and go to Deconstruct BREP. Drop that in here, connect that. So what that does is now allows me to have the faces, edges, and vertices of the BREP. So every time I add a new plug here, I want to turn the preview off on the old one, otherwise they just start to overlap each other and it's hard to tell what you're looking at. We'll just keep what we're working on fresh and highlighted. So here we can see the difference between the first two is here you can see my vertices are highlighted and the edges are highlighted and the surface and the faces all at once. But I actually, in this case, I'm only concerned with my edges, because what I want to do is take these edges and use them as a way to divide the distance to start to build some horizontal lines that will eventually become my louvers. So how do I select just these two edges out of this whole box? I want to list those items. So if I go to my sets under list, I can go to list item. So the list item plug is going to ask you for the base list, which will be here, all of my edges. So I have 12 edges, and then which individual item or index I'd like out of those edges. So I'll plug it in here, and you can see it's grabbed this bottom one here. That's because the default is set to 0. So I'm going to make a new slider so that I can shuffle through all of my different edges and get the ones I want. First thing I'll do is I'll edit and I'll do a whole number. Because I'm selecting an item, I can only do whole numbers. It's basically 0 to 11 for my 12 edges. So we'll set our max to 11. So I'll plug that here under my item. And now if I slide this around, you'll notice it's jumping from edge to edge, so I can see which edge I'm actually selecting. And so what I want is edge number 8. I'm also going to want this other far side, so I'm just going to take this and this, select them both, Control-C, Control-V. It keeps the same inputs. I just know that I'm going to want multiple edges, so I will copy that out there. And I will also select edge number 9. So I have edge 9 and edge 8. Great. Now what I'd like to do is divide these edges into an interval that can start to relate to whatever this ends up being, whether it's your facade or some sort of program diagram or something like that. So let's go ahead and take this curve. We'll take this top one here. We want to divide that up. So if we go to the curve tab and go under division, we have a lot of different ways to divide things. So you can divide the curve into equal segments. You could divide it specifically by the distance between points or by a specific length. For this, what I want to do is actually divide by a specific length, because I want to have some control over where my divisions happen, and maybe that I want that to relate back to a real life scale at some point. For this, it's going to still be quite conceptual, but I want to design it such that it can be more applicable to real situations. So we'll just take my curve and plug it into the input that's looking for the curve to divide. Right now, the length is set, it's at empty, which is why my plug is orange. Gray means it has some inputs, and of course, red means it has the wrong type of input, which we'll get to that in a bit. So how many segments, what is the length of my segments? I'm gonna make a new slider. And I'm gonna do it, I'll round it to 1 decimal place, and I'll make the max 5, we'll say. So it'll be 0 to 5 with 1 decimal place. And we'll put that in my length. And I'm going to just manually type in 1.5 as my length to start with. So what I've done here is I've just simply divided this curve into 1.5 foot intervals. And you can see all these intervals here. I'm going to do the same thing with my opposite end curve. So there we can see those pieces at the end there. And so now what I'd like to do is simply draw a line between them. And I'm going to do this the wrong way first, just to see a very common problem, and then we will solve that problem. So to make a line, horizontal line between all of these points, we simply go to our curve tab, and under primitive, we'll just do the most basic line from A to B. So point A is all of our points on the left side, and point B is all of our points on the right side. But what happens? See, our lists are flipped. Grasshopper has no way of knowing that this list started from the top and this list started numbering from the bottom. So if we type panel, this is a great way to just start to look at your data and see what you actually have going on here. So I'm just going to put in my points here and see what I have. So here are all those points, right, that I divided, or let's do it on the top one. Here are all these points, and it gives you their points in space, right? So point 0 is at minus 100, minus 20, and 20. And here are these points. So point 0 here is at 100, minus 20, and minus 20. So you can just see by point 0 is clearly the on the far right, they're all at 100. So they're all over here. And if this is at minus 20 in the X and the Y, this is at minus 20 and plus 20. So we know right from the beginning that point number 0 and point number 0 here are different. One's at the top and one's at the bottom. And when this is drawing a line, it's drawing a line from item number 0 to number 0, and number 1 to number 1, and 2 to 2, and so on. So to get these to speak to each other, we simply just need to flip the way that this division is happening. So under our curve tab, we go to utility, we can flip curve. I'm just going to plug that in right before we put the divide that curve. So this curve here, we're basically flipping it here. So the curve is the flipped curve, and now let's divide the newly flipped curve, and now we can see it matches on both sides. And now when we draw a line between them, it's just a straight line. So a little bit of a complicated way to draw straight lines, but it's important that we have everything entirely built within Grasshopper because it'll allow for maximum editing as we move through. So let's get rid of those panels. We'll keep adding these panels to help explain how the data is working and not working so that we can troubleshoot along the way. All right, so we've created a very simple set of lines connecting. But right now, these lines are parametric in that if I change the size of my box, they all stay connected and keeps everything from the very beginning editable all the way to the end. So now let's break down those lines even further into a set of points. One of the ways I like to think of working in Grasshopper is starting from the complex and working your way down to the simplest point of manipulation, and then building back up from that simple point. So it's very easy to manipulate points in Grasshopper. It becomes more difficult to manipulate surfaces. So when you can, the best way to start to think about how to create what you're doing is what are all the points that are going to make up the final output. So in this case, when we think of louvers, we could think of louvers as being extruded from a curve But then we can think of that curve being created from a series of points. So here's our curves, right? These are our straight lines. But if we break down those lines into a series of points, then we can move those points and then recreate a new curve along the new points. So here's our line. Now let's break it down into a series of points. So if we go division again, and this time I want to do an equal segment. So I'm just going to go to divide curve because I don't really care how far the points are between them from the specific. I just want a uniform division that'll give me a sort of a sense of, you know, fluidity for how much or little I break down those curve points. So here's our divide curve. It's looking for the curves to divide. We'll give it these lines, the number of segments, and if they're split at the segments, which we don't want them split. We still want cohesive lines. So we can see here, if we break down those curves into that many pieces, the segment or the default in here, which is 10, it's going to be a little bit of a chunky line. So let's give it a little more fluidity and add a slider. Actually, I'm just going to copy a slider from over here and plug it in. And, well, maybe edit that. Let's make the max 20. Okay. Let's see, what did I do before? Yeah, 20, that should be good enough. That should give us a good amount of definition. And I'm already breaking my own rule. Again, I wanted to turn off all this old stuff so I don't need to see all this old stuff. Just, well, we'll keep that on so we can get the sense of the scale. Don't need to see these lines anymore. I'm really just worried about these points. So now what I want to do is I want to move these points in space. And particularly, I want to move them in the Y direction, but I want to move them relative to their distance to this curve. So this curve is drawn in Rhino. Very simply, you can just go into your front elevation and just draw any kind of curve you want in there. I just have this kind of, you know, enough shape in it to give you an idea of how it works. So how do we connect something we drew in Grasshopper or in Rhino to theoretical points that are only being shown through Grasshopper, these green points here? First thing we need to do is actually bring the curve from Rhino into Grasshopper. So if we go to our parameters tab, go down under geometry and go to curve, plop that right there. You'll see it's orange, it has no data. I'm going to select it and then right click and go to set one curve, and then I will set the curve. You can see it's green, so now in Grasshopper, when I click on it, it's green, so now it's in there. So even though it's here in Rhino, it has now been brought in here. So I can actually hide it if I want to. So if I don't want to see it, but because it's just a simple line, I'll leave it there. But it is now in Grasshopper. And if I go in here and I actually adjust the Rhino curve, it automatically adjusts it in Grasshopper. So it's a parametric between Rhino and Grasshopper, as well as the manipulation that we're going to do to it from this point out. So now let's find the proximity between all these points and this curve. So what's interesting about a curve is we're looking for not just to find the distance between a curve and a point. You essentially have to draw a straight line to the closest point of that curve. And luckily it's quite easy. There is, under the curve tab, under analysis, there's a curve closest point. So you can just even see in the little diagram, it's doing exactly that, right? Points floating in space, finding the closest point to that curve. So, which is essentially giving you that proximity to that curve. So we drop that in here. What's it asking for? The points. Well, we have our points here that we just divided, so we'll connect the points to the points. And then it wants a curve to project onto. So we'll give it that curve that we drew in here. And now it shows us all those little points. What those is basically just the points where if you drew a line from here straight to here, it'd create that point. So you can see all the places it would touch as it runs through there. We don't actually need to see those, so I'll turn that preview off. What's more important of the outputs of the points where it touches is the distance. This is the key thing that output that we're concerned with. It's going to give us the distance from these points to the closest point on this curve. So let's look at those distances really quick, because this is sort of the key idea of this tutorial. It's not only how to make these parametric, but to understand how to scale, shift, and control domains. So if I look at all those distances, right, they're it's arbitrary numbers. So this is 5 feet, 13 feet, 20 feet. And if I wanted to make the depth of these louvers relative to this, I don't necessarily want it to make it exactly the same. So I don't want my louvers to be 5 feet, 13 feet, or even like, I don't want a 20-foot louver just because I'm 20 feet away from the curve. What I want to do is adjust a scale that makes sense for louvers based on a scale that makes sense for proximity. So that's really where the key part of this is changing domains to work with each other. So to do that, we're going to need a few pieces, and these are all under the math section. So under the domain tab, there's these three things that always I like to use together, and it's easiest to remember them to just remember that there's three. There's the bounds, there's remap numbers, and then there's construct domain. So these three pieces work great. The remap numbers is going to do exactly what we need to. It's going to remap and sort of rescale our proximity into something that makes sense for a depth of a louver or whatever object you want to transform this into. So let's see what it's looking for. At first, it wants a value to remap. Okay, so that's going to be the distances. And then it wants to know what's the source domain, and then it wants to know what's the target domain. So what's the source domain? Essentially, what's the maximum and minimum of the initial domains? So if we were, maybe we'll keep that panel out just to explain what we're looking at here. If we look at all these distances, right, what's the maximum minimum? I can scroll through here and figure it out, right? But there's hundreds of points here. But all I care about is what's the smallest point and the biggest point. By using this bounds tool, I can plug this in here, and this data I'll need to flatten so that I'm seeing the entire list. And I'll explain a little bit more about flattening data in a minute. But for now, just right-click on the N and click on flatten. And when we now plug this into our panel, what we can see is that the very smallest distance is 0.06. So that's one of these points right here, which is really close. And the greatest distance is 33. So that's probably right here going to here, right? That's the farthest distance that it is from one point to the curve. So that's our domain, the max and min of our distances. And so that's going to be our source domain. So we'll plug that in here. Now this is the domain that we are creating. So this is going to be the max and min of a louver size for this particular example. So I'm going to make a slider. And I'm going to edit it. We'll give it maybe one decimal place. And we'll say the maximum is 10, which might be crazy for a louver, but just so we can clearly demonstrate what we're doing, that'll be fine. I'll make a copy of that. And so we'll say A is my low end and B is my upper end. So I'll just throw this up here somewhere, leave this kind of low here, plug that into my domain. So essentially I have a 0 to 10-foot domain for louvers, and I have a 0 to 33-foot domain for the original distances. So I'm going to put that into my target. And what I now have is my remap numbers. So what that does is it takes the smallest number, 0.06, makes it 0. The biggest number, 33.42, and makes it 10, and readjust everything in between. So now that I have those remap numbers, you can see it's not even displaying anything in Rhino. It's because it's just data. I have to still do something with that data. And so what I want to do is just use that data to actually move these points in the Y direction. So let's go to our transform tab, and under the Euclidean, we will go to move. Very simple command or plug. It wants the base geometry to move, and it wants the translation vector. So if you remember how vectors work, they need a distance and a direction, or a direction and an amount. So the geometry to move is going to be all my points right here. So remember these points, or not these points, original points. So you can see right now they all just went up because the default is set to move 10 in the Z direction. That's not what we want. We want to move it based on all of these points, but these points don't have a direction. They just have a distance. So we need this distance plus a direction. So to do that, we can just go to the vector and go to our base vectors and just pick the Y vector. So by plugging all of our distances into a Y vector, now we have those distances in the Y direction, and then we add that to our translation vector. So now we can see all those points. You can see those points have been moved, and they are, you can see that they're relevant to the actual curve itself. One of the things you'll notice is that they're moving in the wrong direction, right? They're going sort of into my building, even if I switch the relationship. So what I want these to do is go the opposite direction. So one very simple way to do that is just to make all of these numbers negative. So, if I go here to my vector tab and go to reverse, it's a very simple way to just make them all go the opposite direction. So they're leaving my facade and not going into my building. So I'll just go that into there, reverse my vector, put them in here. Now it's all going out the other way. There. You can see it a little bit more clearly there. So now you can see that they're clearly going out, and they're going out based on how far they are from that point. So that's starting to look like what we said we wanted to do from at least a points in space standpoint, but obviously this isn't quite louvers yet. So now we need to start thinking about how we can translate these points and make them back into a more realistic design. So the first thing we can do is simply just make a curve. So again, thinking about a louver as a thickened plane is defined by the original curve, and that original curve is defined by points. So we started at here at lines, we broke it down into points, moved those points. Now let's turn it back into lines. Then we'll turn it into a surface, and then in turn thicken that surface into a poly surface. So first thing we can do is connect these lines. So if we just go to curve under spline and go to a NURBS curve, which is just sort of your standard curve in Rhino, and put our points into the curve control points, you can see it makes these curves based exactly off these points. So we've sort of created the outer limit of this louver. And now one easy way to make a surface between the surface of our, abstract building and that is just to simply loft between that and the original lines. So let's just copy our NURBS curve and make another set of curves from our original points here. So we have curves that run perfectly flat and straight based off of the original, and then we have curves based off of the moved points. So before we did all this transitioning down here, and then after. So we have these two different pieces. And now that we have those two sets of lines, we can simply just loft them together to make a surface. So under freeform, we can use the loft Here, the way the loft works is it actually just wants you to put all the curves that are going to be lofted into one single plug. So I'll put my flat original curves in first, and then when I bring my moved curves based off of the drawn line here, I'll just hold shift while I put that plug in so that it has two plugs. And now if I turn off all of this mess, we can see the lofted surfaces that it's created. So these lofted surfaces are now between this line and this line, which is starting to look slightly more like louvers. Turn off some of this other noise. And then from here, I can simply extrude that surface to make it feel a little bit more like a thickened louver. So under freeform, I'll just extrude. Extrude's going to want the base curve or surface, so we know what our surface is, but it also wants to know the extrude direction. So again, we'll go to vector, and in this case, we want to extrude it in the Z direction, so that would give us a thickness, basically the up direction. And then we'll make a slider to define how much we want to move it. So in this case, 0.25, so that's a quarter foot, which is 3 inches, which is maybe a good starting point. I'll plug that in, so now I have a quarter, 3 inches in the Z direction, and then I'll use that as my extrusion direction, and now we can see that my louver has some thickness and is completely parametric based off of the curve in Rhino. So let's just quickly explore what we can do with these parameters, and then we'll bake it in and we'll call it good. So again, the thickness is a sort of analog direct input, right? So I can just change this thickness to anything I want. If I wanted them to be 6 inches thick for whatever reason, I'd change this to 0.5. And now we have some thicker louvers here. Maybe these are, something else. They're more of a shading screen and less of, a typical sunshade. So here, that's sort of a direct analog input. Again, if we wanted to make this relative to another thing else, we can sort of build off a new definition where the results would end up being the thickness, but we'll leave it simple for now. Our domain is also something that we have control of. So the max is at 10, but let's say I wanted to keep these a little shallower, maybe it's a little bit more subtle. Our max can be 5. Let's say I didn't want it to get so small where it's really skinny at the end. The minimum can be, 0.5. So maybe we're saying it's a half foot to start and, 7 feet at its most extreme. So all of that is parametric as well. The divisions are, so you see when I break this down, you can start to see that it gets a little bit less fluid and sort of flattens out as we have less control points for our curve. So more control points, the more fluid our curve looks. And then, of course, we have our division length, right? And so since I want this division length, remember we divided the short and far end of the curve. I actually want these to be the same, so I'm just going to use my same divider here. Delete that. So here, if I change this, you can see I get much less. Let's say there's only a louver every 3 feet. It's sort of a less exciting version of it. Maybe this is a really dense screen and there's a louver every 1 foot and they're a foot thick. So you get this sort of AB off on and a much thicker, almost wall-like version. It becomes almost like a fluid wall itself, which also can be kind of interesting. So let's say we want to leave that there for now. And again, of course, if you go all the way back to the beginning, what's really great about this and what's really great about having our initial surface in Grasshopper as opposed to me just making a surface in Rhino, which we could also have just made a surface, brought it in to Grasshopper by using the parameters and just bringing in a pre-made surface. But I wanted to show you bringing in the original, making everything from scratch so that you can see how here, if we wanted to come back and adjust the overall width, it all still works. Even you can see it just is not concerned with the part of the curve that is not next to it anymore. But everything is able to be controlled without having to remodel anything. So let's say we have these parameters where we like them, sort of just a nice little subtle flowy wall here. Exaggerate this a little bit more. There we go, that's kind of fun. Here is our actual louvers. It's the final piece of the end. When I select that, what I want to do, well, first is to go into Grasshopper or into Rhino, and I'll make a new layer and call them louvers. Double click on that layer to make sure it's the current layer, and then in Grasshopper, I'll select this layer, I'll right click and just click bake. It'll give me a lot of attributes to look at. I'll just leave all the defaults and click OK. And then I'll come in here and turn the preview off so I'm not seeing it, minimize that. And now my louvers are baked into Rhino. Change the color of this so you can see it a little better. So these are now baked in as actual objects. What I like to do is, what's great about this is you can start to bake in multiple iterations and then come back and start to compare them one by one to see what's really giving you the effect you're going for. So if we just call this louvers option 1, go to our louvers option 2. Maybe we'll turn off that original layer here. Let's pull the Grasshopper definition up, put this on. So now let's compare that to our, maybe a louver that's not as thick, that's maybe a little bit more depth at the maximum, and let's say it's not as dense either. Maybe it's like every 2 feet. So generally completely different look and feel than that first option. We'll come back in here. We'll bake this. Turn it off. Just make this black so we can compare it. Now we can quickly see option 2 versus option 1 and start to make some design decisions about which one is really giving us the look that we actually want to go for. And so we'll leave it at that. In the upcoming tutorials, we'll get into more detail about some of the nuances and start to add some more ideas to our tool set, and then start to combine those ideas to really make truly parametric and interesting designs. Thanks.